Hello everyone. First of all, I would thank Emertxe for providing this internship on embedded systems. So, I'm Manoj Kumar A from Dayanand Sagar College of Engineering. So here we go. Let's start on washing machine simulator using PICSIM LAB. So, contents of this template. So, what we learned in this internship. So, we learned about C programming, embedded C, embedded systems, types and application of embedded systems, microcontroller, microprocessors, and application of microcontroller also, and embedded systems, real-time application of embedded systems, and about PICSIM LAB. So, table of contents. What are the table of contents? So that we have embedded systems and tool used for this project and problem statement, embedded system requirements, washing machine automation, scope of this project, system or software requirements, PIC16877 architecture, PIC16887 board schematic, CLCD, digital keypad, and timer. Yeah, let's go. So C program. What is C programming? So C is a general purpose programming language created by Dennis Ritchie at Bell Laboratories in 1972. So C is effectively used in various specific domains, and it is free formatted language and efficient because of its efficiency and portability. It has a number system, decimal, octal, hexadecimal, and binary system. So data representation is done bit, byte, and word. Data types are characters and int, floating points are float and double. So if we consider conditional statements, so single iteration we have if else if, and switch cases. For multiple data iterations we have while, do while, for. For unconditional we have continue and break statements. Next, so classification of C tokens. C tokens are classified into 6 types, such as the keywords, identifiers, constants, strings, special symbols, and operators. So what is an embedded system? Basically, if we consider an embedded system, any combination of hardware and software which is intended to do a specific task. It is intended to do a specific task is called an embedded system. So categorize standalone real-time network and mobile. So challenges that are faced is efficiency, input or output, embedded as an OS, code optimization, testing and debugging. An embedded system is a small computer that forms a part of large system, devices or a machine. Its purpose is to control the device and to allow a user to interact with it, and they tend to have one or limited number of tasks that they can perform. So types of embedded system. So in this we have 4 types of embedded systems. One is a mobile embedded system, standalone embedded system, real-time embedded system, and network embedded system. If we come for mobile embedded systems, mobile embedded systems are embedded in mobile phones and cameras. These types of embedded systems can be seen in the mobile phones, like if you see a processor, chipsets, and cameras too. So if we come to standalone embedded systems, standalone embedded systems works by receiving the input without using any ghost system for desired output. If we come to real-time embedded system are designed to perform a specific task within a time frame. So network embedded system are usually used for general purpose processors. So yeah. So where and all the embedded systems are used. So the embedded system, as you can see on the picture, embedded systems is used in automotive, military, industrial applications, consumer applications like cameras, and communications and medical uses too. So what are the components of an embedded system? So the components of an embedded system include a CPU, which is a central processing unit. It is the heart of embedded systems, and it also has analog to digital conversion and digital to analog conversion too, and FPGA or ASIC, and it has also inbuilt memory. Human interface is obviously required, diagnostic ports and auxiliary system. So if we take for example, sensor gives an input to the embedded system, it can unlock to digital conversion, convert it into digital form, and CPU will process it, and digital to analog conversion will happen, and the analog output is provided to actuators, and this is a feedback loop. So examples, embedded system example. For taking an if you take washing machine as an example for embedded system, it has many embedded systems like input buttons, say output display, and motors, control units, processors, ROM, and software as well with software. So problem statement. So what is the problem statement for this washing machine simulation? To develop a washing machine interface and simulate it with which displays and allows user to select different types of washing modes on pressing a digital keypads and water levels on long press. On start of the washing machine, it should display functions running and remaining time, and also it should stop when the lid is opened. These are the functionalities we are implementing in the washing machine simulator. So next, so what are the software required? Software is, we need a, first of all we need a IDE to write the code and create a hex file. So we are using a IDE, means integrated development environment, where you can write codes. So we are using a MPLABXIDE. So Microchip Technologies MPLABXIDE integrated development environment is an expandable and highly configurable software program that incorporates powerful tools to enable designers to discover, configure, develop, debug, and qualify embedded designs for most Microchip microcontrollers and digital signal controllers as well. So MPLAB supports project management, editing, debugging, and programming of Microchip 8-bit, 16-bit, and 32-bit PICSim microcontrollers as well. So the compiler which are using, there are different types of compilers for this. So the specific type of compiler we are using is XE8 compiler. So XE8 is a C compiler for Microchip for 8-bit PICs. If we consider PICSIM LAB, it is 8-bit. Both programs run on Windows, Mac OS, and Linux as well. It is platform dependent software, XE8 compiler. And MPLAB IDE is also a platform dependent IDE for Windows, Mac, and Linux, for all three of them. So PICSIMLab. PICSIMLab is a real-time emulate of development boards with integrated MPLABX debugger. For code editing and debugging, the same tools used for real board should be used with PICSIMLab, such as MPLABX or Arduino IDE. So PIC PIC16F877. So PIC16F877, the features of this are it consists of 256 bytes of EEP ROM data memory, self-programming, an LCD. It consists of an LCD. It has 2 compartments with 8 channels of 10-bit analog to digital converter to capture, compare PWM functions. The synchronous serial port can be configured as either 3-wire serial peripheral interface or to the 2-wire inter-integrated. So PIC16F877 is a 40-pin PIC microcontroller designed using RISC architecture, manufactured by Microchip, and is used in embedded projects. It has 5 ports on it, starting from port A to port E. It has 3 timers in it, 2 of which are 8-bit timers, and while other one is 16-bit. So next, so this is a PIC16F877 board architecture. If we consider next, which is this is a PIC16F877 architecture. The previous one is the board architecture. So the architecture consists of GPIO pins, general purpose input output pins, I2C ROM, LM365 temperature sensor, and an analog to digital converter. It also consists of CLCD and a matrix keypad, and SSDs, which is solid state drives, digital keypads, buzzers, LEDs, RS232. So LEDs, simplest device used in most of the embedded application as feedbacks. So it works like a diode, low energy consumption, higher long life, smaller size, and faster. These are the advantages. Switching makes it usable in wide application fields like home lighting, remote controls. The remote controllers we used as IR and display, and many more. So CLCD interface. CLCD is a liquid crystal display. LCD is an output component and is used for display characters. In PICSIM lab there are two types of LCD displays, which is a 16:2 and a 4 display. So it displays the ASCII characters and some special characters as well. There are two types of communication modes, like 4-bit mode and 2-bit mode. The further we go, it has the digital keypads. Digital keypads is mainly made of tactile switches. The tactile switches are turned on when the key is pressed. It is off when it is released. In PICSIM LAB PICGenoise board, digital keypads keys are interfaced in pull-up register format. When the switch 1 is pressed, the RB0 is 0. One of the problems faced in digital keypad is bouncing effect. It has nothing but spurious pulse detection while pressing or releasing the tactile switches. One of the major problems faced in this digital keypad is bouncing effect. It is nothing but spurious pulse detection while pressing or releasing the tactile switches. So the matrix keypad, used when the more number of user input is required and still want to save the controller input output lines. Uses rows and column concept, most commonly used in telephone, digital lockers and calculators and many more. In the cooking mode, the matrix keypad keys are used to select the respective modes. The tactile keyboard, a key switch is tactile if it has a bump in response to finger pressure at or near the engagement point where the key press register and before the key bottom out at the end of its travel. A keyboard is a tactile if it made with tactile key switches. So tactile switches. Two types of operators, level triggered and edge triggered, as we all know. A tactile switch is one type of widely used switch that completes an electrical circuit typically when pressure is applied to the device by the users, which then gives the user with a perceptible click at or haptic bump in response, indicating current flow. Current flow is turned on when the switch is released. Switch bouncing effect. What is the switch bouncing effect? When we press a push button or toggle switch or a micro flow switch, two metal parts come into contact and short the supply, but they don't connect and disconnect several times before the actual stable connection is made. So ISR fans and buzzers. So what is an ISR? ISR is the interrupt service routine. ISR tells the processor or controller what to do when an interrupt occurs. So fan is something but an onboard or passive cooling fan are now mostly used in desktop computing and embedded systems. So buzzers. In embedded system, buzzer is widely used to notify various events such as interrupt generator, end of the processor, and in emergency situation like detection or fire. So timers. It has three modes like PWM or pulse generator, counter, tick, up count or down count. In the quantum is system clock. It is system clock settings, scaling pre or post, resolution, register width. The micro mode and grill mode are under the operational mode. The timer is set with the matrix key pass star to clear and hash to enter. To toggle the LED, 8-bit resolution is required. So this is the program flow chart. If we start with declaring variables, reset mode, program water levels and arrays, and configure the initial files for keyboard, LCDs, buzzers and timers, and we show start screen, and wait until the input power is on the washing machine, and super loop file. Take key pressed input and configure reset mode and operation mode, and and lastly display screen based on the operation. Yeah, thank you. Yeah, so now we are going to implement the washing machine and simulate the washing machine. So we have here the MPLABXIDE for washing machine simulation. So here we have the washing machine simulator files. All the necessary files required are here. So let's start with building the code. So as soon as we build the code, it should show the build is successful here. As soon as the build is shown, it shows the build is successful. An X file is created. So we have to input that X file in the PICSIM board here. This is a PICSIM LAB simulator. First of all, we have to load the X file here. This is an X file which we have recently simulated, which we have built. Just load it to the PICSIM lab. We have to select we have previously selected the board, which is a PICGenoise. Okay, as you can see here, PICGenoise board, and the microcontroller used here PIC16F877A microcontroller, as I have previously loaded in. So if you want to switch on the washing machine, it shows here press key 5 to power on. As soon as you press key 5, it will show power on, powering on here. The washing machine is powering on right now. Further, it shows all the washing machine programs like daily. Press this button to switch through the programs. You can see the programs are delicate, whites. Further, we have stain wash, eco cottons, woolens, bed sheets, rinse plus dry, and further we have it's just taking too long. And dry only, wash only, aqua store, daily, heavy, delicates, whites. These are the programs, and eco cottons. If you want to select a particular program, just long press that key for some time. It will select that particular program. Now it takes some time to select that particular program. As you can see, it will show the water level, the amount of water you are using here. So we have auto, low, medium, high, and auto, low, medium, high. So if you want to select a particular program, just long press it. Long press the same key to select the water level. I have chosen here auto. If you press the long press the same key, the auto water level will be selected. As you can see here, press switch 5 to start and switch 6 to stop. It is not showing here right now. If you had a larger display, then it will show. As soon as I press the switch 5, it will start. Sorry. Just take the washing machine program, which is daily, long press, auto water level to long press, to set the water level to auto. And press key 5 to start. It is started. Program which is daily, and the time here is 41 seconds. So the function wash is being run right now. If you want to stop, just press the 6 key to stop. So as you can see, it is stopped. To start, just press the 5 key, switch 5 key. So it will show the function and time taken to complete the washing. It is washing right now. The fan is turning on. Just wait for some time to complete the washing function. Now the rinse function is on for the washing machine. Now the spin function is on. 18 more seconds to complete. Ten more seconds. Yeah, the washing machine simulation is done. Yeah, the program is complete, and remove the clothes. So I would like to thank Emertxe for providing us the wonderful internship. Thank you very much.